so we'll get, like I said, I'm gonna go through these relatively quickly, cause we've seen them all before. So we've got a linear function, the parent function is y is equal to x with a slope of one, a y-intercept of one. The domain there, all reals, same on the range, cause it goes forever in both directions. X-intercepts and y-intercepts, 0, 0. There are no extrema. You increase from left to right, from negative to positive infinity here always. Decreasing intervals are none. Alright, in behavior and in pre-cal, we do have to write this out. They don't pre-print it for you. So as x approaches infinity, f of x approaches negative infinity, we don't really give you enough room. And then your other one is as x approaches negative infinity, f of x approaches negative infinity. So they match for linear. There are no discontinuities here, and this is an odd function with symmetry at the origin. Some of these things we didn't really talk about last year, but we'll talk about them this year. Alright, so that's linear. Absolute value would be y is equal to the absolute value of x. Domain is all real for the parent. The range is going to be greater than or equal to 0 for the parent. Both of these are also 0, 0 here. I'll stop making a question. There is an extrema at 0, 0. It would be considered the absolute minimum. It increases from 0 to infinity, and it decreases from negative infinity to 0. Remember, we read those from the left to the right. The in behavior, I'll try to write this way, as x approaches infinity, thank you, f of x approaches infinity, and as x approaches negative infinity, so on the left side, in this case, f of x also still approaches positive infinity here. Okay, the discontinuities, there are none. This one is an even function, I'll just circle that one, which means its symmetry is about the y-axis. And again, this is the parent. That's going to change if we slide the graph over or whatever, but for the parent, that's how that's going to stay. Okay, I mean, it stays even, but the symmetry would move from the axis if we slid the graph over. Okay, so here is your parent function for quadratic. Y is equal to x squared. Domains all reals. Range here also greater than or equal to 0. Intercepts are 0, 0 here. Extrema, same as the absolute value. You have an absolute min there. So I'm not going to write that out all the way. Alright, it increases from 0 to infinity and decreases from negative infinity to 0. The in behavior is going to match that of the absolute value. So as x approaches infinity, f of x approaches infinity. Excuse me. As x approaches negative infinity here, f of x still approaching infinity, so going up. Okay, discontinuities, there are none. This one is even. Symmetry about the y-axis there. Okay, so still nothing new. Y'all seen all of these. Alright, this is your cubic, so y is equal to x cubed. It has a domain of all reals and a range of all reals. Its arrows go in both directions. Intercepts also 0, 0 here. Extrema, there are none. It does have this, what we would call a critical point right here where it turns, but there's no extrema. Let's see, increasing from negative into positive, since it's a positive function. No decreasing on this graph. As x approaches infinity, f of x approaches infinity, as x approaches negative infinity, f of x is approaching negative infinity. They go in opposite directions. There are no discontinuities here. This is an odd function, so the symmetry is at the origin. Everybody okay with all of those? I know I went through them pretty quick, but I've seen them all before, so. Any questions at all on any of those? Okay, alright, so we'll go to the back here. This is your square root function, so y is equal to square root of x, and like your fourth root looks the same as your square root, y'all remember that. So the domain here would be x greater than or equal to 0. Y is also greater than or equal to 0 for this particular graph. Intercepts are still 0, 0. Most of those are what that's going to be for parent functions. Your extrema, we also have an absolute min here. This function is increasing from 0 to infinity. I did use the bracket on that because that's a distinct beginning point. Y'all okay on that part? No decreasing here. Alright, in behavior, these are the ones that can be a little bit tricky. So as x approaches infinity, f of x also approaches infinity. But on the other side, as x approaches 0, f of x is approaching 0. Because we have a distinct point there. Y'all okay on that part? Alright. No discontinuities, and it's not even or I guess I've got neither there instead of even. It's neither even nor odd. Good there? Alright, so then we have the cube root function, so y is equal to cube root of x, and all your odd ones are pretty much, they look the same. Domain all reals, and by odd I mean odd roots. Range is all reals. These are both 0, 0 here. Your extrema, there are none. This one increases from negative to positive. There are no decreasing in behavior as x approaches infinity. As x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. Discontinuities, there are none. This one does have a critical point and a turning point, but it's not an extrema. This one is odd, so it's symmetric at the origin. Okay, good there? Alright, the reciprocal function is y is equal to 1 over x. We did see this one last year. So here when we write the domain, we have to write x not equal to 0 because there's a vertical asymptote there. Same thing on the range. Y is not equal to 0 because there's a horizontal asymptote there. There are no intercepts for this particular graph because of the asymptotes. Obviously, if we shifted that graph up, down, left, right, that would change that a little bit. There's no extrema. This particular graph does not increase at all. Are y'all okay on that one? Like this one does not increase at any time. So, and the decrease is going to have to be like written as a union when there's not enough room. So I'll kind of write it. I'll stack it here. So we would have from negative infinity to 0, and then union from 0 to positive infinity, and there's a parentheses on the 0 because 0 is not included. Y'all okay there? On that one? Okay. Alright, so as x approaches infinity, this is another one that's a little bit tricky. F of x approaches 0 because it's approaching the asymptote here. Same thing on the other side. As x approaches negative infinity, f of x also approaches the asymptote of 0. The discontinuities on this would be written at x is equal to 0, and it is an infinite discontinuity. Did we do discontinuities last year, the different types? Okay, we'll talk about them in this unit then. I can't remember if we did them last year or not. So it's infinite because it's not just a whole, it's like a whole line, so there's always a discontinuity there. This is an odd function, so it's symmetric at the origin until it shifts. Okay, this is an exponential function, so we usually use 2 to the x as the base for that. Domain, all reals, range is going to be greater than or equal to 0. There is not going to be an x-intercept because of the asymptote there. Y-intercept's at 0 and 1. There's really no extrema. This increases from negative infinity to positive infinity, and it does not decrease. Alright, in behavior here, as x approaches infinity, f of x approaches infinity, and then as x approaches negative infinity, f of x is approaching 0. Discontinuities, there are none, and this one is neither odd nor even. Okay, so some of those things we haven't discussed a ton, we'll kind of get into them on these, but these are all graphs that you did see in Algebra 2. It's just been a while since we've looked at them. Some of those details we didn't really look at in Algebra 2, but we'll start looking at here. Everybody okay so far? Alright, so we're going to take a look at a couple of these. The logarithmic you have seen, y is equal to the log of x. We didn't do much with it, but you did see it last year a little bit. So here, x is greater than 0, and our range is all reals. The x-intercept's 1, 0. Remember, this is like the inverse of the exponential. It's kind of it's flopped on it's flipped across the axis line, or y equals x actually. The y-intercept is none. Extrema, there are none. We are increasing on this one from 0 to infinity. It does not decrease at all. In behavior, as x approaches infinity, f of x approaches infinity. And on the other side, as x approaches 0, f of x approaches negative infinity. Y'all okay on that one right there? A little bit tricky. There are no discontinuities, and it is neither even or odd. Okay, so now we're going to look at a few that you have not seen before, and I'll talk about them a little bit as we go, but not a ton, because we're not going to do a whole lot with these at the moment. So the ones that I covered so far are going to be the ones that we're going to spend the most time on in this unit. The great integer function looks kind of like this. That's kind of the way it's written. So I just draw a bracket with a little line through it. It's kind of the best way to draw that. Okay, so the domain on this function is all reals. But the range on this function is all integers. A lot of times it'll be written like symbolically with the Z, but I will write it out. So what that means, like with this, is like if we look at on these range values, like the graph doesn't touch anything in between here to here. Does that make sense? It like jumps. And so that's why it's called a greatest integer function. So we either round it up or you round it down. So the x-intercepts here are gonna be at 0, 0, y-intercepts also at 0, 0. There are no extrema. I said we won't spend very much time on this graph at all. We'll talk about it a little bit, but not very much. Increases from negative infinity to positive infinity, does not decrease. As x approaches infinity, f of x approaches negative infinity. And as x approaches negative infinity, f of x approaches negative infinity. So it's a whole lot like the linear function. So the discontinuities on this, it's called a jump discontinuity, is the type that it is, and it jumps at every integer. So we jump up from the whole to the solid, whole to the solid, whole to the solid at every integer. So that's what's called a jump there. And this one is neither even nor odd. I said we'll do very little with it. I just want you to at least have seen it before. Okay, y'all okay on that one? Alright, so this is the sine function. So y is equal to sine x. We will deal with the sine, the cosine, and the tangent, which isn't even on here, in the second half of this class. Like we spend the whole second half of this, like the second semester, on trig functions. And so we really won't get to it till then, but I'm gonna go ahead and show it to you now. So its domain is all reals. Its range is from -1 to +1 for the parent function. X and y intercepts are both at, it's written like this. So 0, 0 plus, and the way this is written as k pi, because if you look on your x values, they're written in terms of pi. That's how we have to graph sine and cosine functions. We'll talk about y a little bit later. K represents some constant value. So what they're saying is we start here, and at every 1 pi, 2 pi, 3 pi, 4 pi, and the same -1 pi, -2 pi, -3 pi, it's going to have an intercept. Is that logical? Y-intercept 0, 0. All right. So the extrema here is written like this. And like I said, I'm not really going to get into the explanation on this now because I'll hit it when we get the second semester. It's going to get the basics on here. So k pi over 2 for your x value, and your y value is 1. That is in absolute max. And then your absolute min will be at -k pi over 2. And -1. So that's your absolute minimum for that. And again, I'll explain what all that stuff means when we get to it a little bit later. Alright, so your increasing interval, these are also written kind of weird and they don't give you enough room. So it increases from -pi over 2 to pi over 2. And then plus 2k pi. And that has to do with a cycle. And again, I'll address that a little bit later. I just want you to get it down for now. The decreasing is at pi over 2, 3 pi over 2, plus or minus 2k pi. And that's because like it increases, decreases, increases. I mean, it's what we call a cyclical function. So it happens over and over and over and over again. and the cycle is 2 pi, so that's how that works. All right, end behavior does not exist, because it does not end. Okay, discontinuities, there are none. And this is an odd function, symmetrical at the origin. Okay, and cosine is pretty similar to that one. So y is equal to cosine x. The cosine function is kind of like the sine function, it's just shifted over a little bit. Domain is also all real, and the range is -1 to +1. So that part's the same. Alright, the x-intercept on this one, the first one's not at 0, 0. The first one is at pi/2 right here. So it's going to be at pi/2 and 0 plus every k pi. Your y-intercept is at 0, 1. Alright, extremas are kind of like the others, or like your sine function. It's written a little bit differently though. It's 2k pi and 1. That's your absolute max. And then negative k pi and -1 is the absolute minimum. Okay, again, these increasing and decreasing, they're because of a cycle. I wish I gave you more room. So this is going to be pi 2 pi, and then plus 2k pi. And for the decreasing, it's going to be -2 pi, pi, plus or, oh, that should be plus or minus, sorry. Plus or minus 2k pi. Alright, again, the end behavior does not exist. There are no discontinuities. This one is even at the y-axis. Okay, and again, when we get to sine and cosine the second semester, I'll cover that in more depth and explain all of that. I just want you to have that as a reference.